Hi, welcome back to the channel. So in this video we will see operational amplifiers in detail. Okay. So in short form we'll call it as op-amp. So op-amp having a symbol, definitions, many definitions, configurations, applications. We'll see all those. But at this moment we'll see what is the definition of op-amp. Op-amp is basically a difference amplifier. Means it is going to take two inputs, make it difference, and it is going to amplify that difference, and it is going to give the output. Basically, it is a difference amplifier, right? So, symbol how it is going to look like. It is having five terminals. It is having how many terminals? Five terminals. First one is called as inverting input terminal. Second one is non-inverting input terminal. So these two are input. Inverting input is minus, non-inverting input is plus. Inverting means it is minus, non-inverting means it is plus. So this is pin number 2, it is pin number 3. So these two are with respect to inputs. So op-amp is having how many inputs? 2, right? Next. So I will write the third and the fourth with respect to what? With respect to power supplies. So here positive power supply, negative power supply. Positive power supply is pin number 7, negative is pin number 4. So these two are power supplies we will be having, positive and negative. Last one is output. It is pin number 6. So 2 and 3 are input, 7 and 4 are power supplies, output is 6, right? So these are the 5 terminals of op-amp. So it is going to do the difference between what it is going to input, and that difference is going to be amplified and it is going to give at the output. Amplification means at the input, assume that you are having 2 volts. If I use the op-amp like this, right? So here two things, one is here and other is one more. Assume that it is 6 and it is 4. What is 6 minus 4? 2. 2 is at this. So this 2 is going to amplify and it is going to get it at this stage. So what is the multiplication factor? 5 times. So 5 times it is going to increase. So at that time it is going to call as gain, that we will see later, right? So that is the meaning of op-amp basically, right? So after this symbols, we will see the characteristics of this op-amp. So here we will call it as op-amp ideal characteristics. What are that? Op-amp ideal characteristics. So we will call the first characteristics. So it is having a infinite voltage gain, right? So voltage gain is represented by A. So AV, so that we will write it as infinite, right? So infinite voltage gain is the first one. Next we'll see this all in detail. First we'll write down the characteristics. Second one is infinite input impedance. That is R input is infinite. Third one is zero output impedance. That is output impedance is 0, like this we should write, right? Next we can write about offset voltage. Input offset voltage, we can write it as voltage input offset as like this, that is 0, right? So similarly we can write the next one, that is we can write as slew rate. One more concept will come, slew rate, that is infinite, and one more concept will come, that is bandwidth, that is also infinite. So anything we have left out is one more very important thing we have left out, CMRR, that is also infinite. So these are the ideal characteristics of op-amp. So we are telling that the ideal op-amp should be like this with these values. Again, this will be having a practical values, right? Suppose if I consider the AV, what is the practical voltage? It is very high. So it is like this, right? So input impedance also very high. Rn is something like this ohm, right? So zero output means, so it is almost practically it is 75 ohm, like this it is having. So we'll see now. In this video, we have seen op-amp symbol and the terminals. Circuit diagram, we can call it a symbol, and here the name of this op-amp symbol is called as 741 IC. Right? 741 is a 8-pin IC. So that we can write like this: 8 pin, 1, 2, 3, 4, 5, 6, 7, 8. We should name like this: 1, 2, 3, 4, 5, 6, 7, 8. Right? So out of that, pin number 2, pin number 3 are connected, pin number 7 and 4 are connected, and output is 6. So it is looking like this. The IC is looking like this, internal configuration. Right? So that is what the video is about. In the next video, you will see what is op-amp parameters and the op-amp configurations in the next section. Thank you.